All right. Hello, everyone. Thank you for attending this Onyx webinar today. My name is Alicia Wallace, and I'm the trainer for Onyx Graphics. Before I introduce our host, I would like to request that all attendees please mute yourself and turn off your video. Please be advised that this webinar is being recorded, and we will be posting a link and letting you know about that when that's available. We'll be taking questions at the end of the presentation, so you can use the chat field to type in your questions, and at the very end, we'll go through the questions. So again, if you could just please remain on mute and have your videos off during our presentation, that'd be wonderful. It is my pleasure to introduce you to Dr. Max Deerhack, who will be presenting today about color check for color accuracy, consistency, and matching standards. Max is the principal scientist at Onyx Graphics. He received a PhD in color science from Rochester Institute of Technology, where Max was instrumental in the development and setting the international standard commonly known as ICC Max. Max is a co-chair of the ICC and is actively engaged in other organizations, including ISO, CGATS, and CIE. Max has been with Onyx since 1990 and has received 10 US patents for his work and leads the product development engineering team on projects that are related to image processing, color management, as well as process control tools. So at this time, I welcome Max. Thank you.
Thanks. Good to have people with me. Those in Europe, good afternoon. Those in the US, good morning. Those everywhere else, good night. We're going to be talking about process control. This is something that's near and dear to me. I like everything about color, actually. And we put a lot of effort to thinking about process control to make it so that it was something that was integrated and easy to use in our software. So to begin with, let's going to ask some questions. And actually, you'll find that I ask a lot of questions in this presentation. So why process control? You know, successful shops, they're generally concerned about lots of things at this point in time. You know, staying in business is one of those things, but that involves satisfying their customers' expectations. You know, customers want their output to be correct and beautiful. You really want to eliminate waste. You don't want to be printing things over and over and over again to satisfy your customers' expectations. In doing that, you want to save time. And you know, if you can do things right the first time, then this really means that you're actually able to be profitable. Because if you're not really doing any of these things, you're not being profitable. You're spending a lot of time doing reprints. Your customers are not necessarily happy, and you potentially lose customers. You know, it's really just important to be able to actually say that you're doing these things. Now, what is process control? Well, process control is basically setting up processes and procedures in your print environment to ensure that you print and do finishing in such a way that it's performed both consistently and accurately. So those are the two words we're going to be thinking about throughout this whole presentation, being consistent and accurate. Now, process control is not a button you push in software. It really requires you to have a mindset of excellence. You need to basically understand, and everybody within the shop needs to have this understanding of what's involved in the printing process and doing things in terms of process control to ensure that we're getting consistency and accuracy. Now, there's various aspects of print shop process control. I'm not going to necessarily be talking about all of these things. In the next few slides, I'm going to be asking a lot of questions about these things. But these are things that are basically involved in process control. And basically, first and foremost, you know, maintenance of your equipment. You know, if your printers are not necessarily printing the same from day to day, then you have a problem. Maintaining a stable printing environment and getting things to print. It could be part of the maintenance, or it could be that, you know, changes of humidity and temperature can, in many cases, drastically affect how things print. Performing proper profiling of and calibration of your printers. You know, if you basically download some profile from off the web, you don't have any idea whether or not that profile is is geared towards the media you do. Or if you just basically go and find the cheapest media and use whatever profile, you're not, you're going to get some color management being applied, but you're not applying process control. Process controls is showing that what you're printing is what you want to print, and you can do it consistently day in and day out. Maintaining the quality and control of the media and the inks. Anytime you change the inks in the printer, you have potentially introduce a change that can change how printing that occurs. The media, how do you control the environment the media is stored? When you get new batches of media, how do you know that that actually is going to print the same as the media that you previously were printing on? Now, key to this is basically ensuring that your printed output is correct, right? And you have some sort of regular evaluation of your printed results. And this is where the Onyx Color Check feature really applies, and really basically going to be the focus of what I'm talking about today. But other aspects of process control really gets into the details, like processes and forms and checklists. What sort of a system do you have set up in your area to ensure that you're basically printing consistently and accurately? Now, these things right here are discussed ad nauseum in the Onyx Color Check Reference Guide, and I really admonish people to consult it for the further discussion of the various aspects of process control and stuff like that. So let's look at some of these things. And what I'm going to do is, rather than talk about what you have to do, I'm going to ask a lot of questions about, have you considered what's involved with these things? So let's talk about maintenance of equipment. So what are you doing to make sure that your equipment is working correctly? Are you doing nozzle checks, self-diagnostics, repairs as needed, etc.? Are you finishing devices, your laminators, your calendars, your heat presses, or whatever it is you're using to actually do the finishing? Are they maintained and operated consistently? What's the maintenance schedule for your equipment? Do you actually have some sort of a schedule to ensure that you're actually your equipment is working as you intend it to work? And if you're using color measurement devices, are they properly calibrated, maintained, and services? If the device that you're using to determine that you're printing accurately doesn't measure accurately, you have no idea whether or not you're printing accurately. Maintaining a stable printing environment. So are you doing things to make sure that the physical conditions are consistent? How is your temperature and humidity controlled? What factors of air quality are maintained to ensure that you don't have dust and fumes, and you've got proper airflow in your environment? And how stable are the print modes being used? Various devices themselves print. Some devices print very, very consistently. Other devices, the technology involved for the printing process is inherently noisy, and you may not necessarily be able to get the same level of stability, but you need to understand how stable your print mode is so you can understand the extent of what is acceptable and when you cross over the line to unacceptable. Proper profiling and calibration of printers. So is your printer in a stable printing condition when the profiling is performed? You need to make sure that you're basically geared up to print consistently, and that starts with making sure that you're printing consistently before you even go into doing profiling and calibration, because the idea of doing those things is so that you can make sure that you get back to this state. And if you're in an unstable state to begin with, going back to it is very, very challenging. Have you performed calibration in the process of getting ready for the printer? Is the color device you're using for profiling and calibration properly maintained and used? Has profiling been correctly performed for the printer and media inks and ink configuration and print mode? Are you basically, do you know that this is actually you're using color management for the actual media and inks that you're using, or are you guessing? Is the printer printing the same as when the profile was performed? That's one of the real key here is what, do you know that necessarily is printing the same? If something has changed, your profiles won't necessarily give you what you're expecting. When do you perform recalibration? And what processes are put in place when things change? Because the real nature of printing is that things are always potentially changing. You run out of media, you put new media in. You run out of ink, you put new ink in. The printer itself um, suffers wear over time. Minimizing those changes or understanding what's going on when things change is critically important. If you don't have an idea that something can change and you don't test for it, you can end up having unhappy customers and lots of reprints. Quality and control of your media and inks. So how is the stability of inks in printers maintained? Some printers, if the printer's not used for a while, the inks can settle and all of a sudden it starts printing differently. How does the media and ink change over time? Really critical question. Um, what is the age of the media or ink being used? Um, you know, media can yellow, ink can settle, or even change color. The chemistry can change. Are you using the same media and ink, and are they consistent with the profiles that are using? And this is a really critical question to understand, because oftentimes people will go and they'll purchase media, and the manufacturer will change the formulation, or the SKU will be slightly different, or even if the SKU is the same, if there can be changes. And how do you know whether or not the media is consistent or the ink itself? What processes are in place to ensure that your media is consistent when you replace and restock it? What processes are in place to ensure that the ink is consistent when you replace or stocked? If other materials are used, what processes are used in place to ensure that they're consistent when they're replaced and restocked? How do you know you're actually getting things consistent? Well, that comes up to basically ensuring that the printed output is correct. First of all, what constitutes correct color output? Do you have an idea of what it means to be correct, especially when you're printing things that aren't necessarily in gamut? I print an RGB image on a CMYK printer. The RGB colors are not necessarily in the printer's gamut. So what does it mean to be correct? What standards are involved in terms of determining what's correct? And what methods are you using to ensure that the results are correct? For this particular thing, in terms of these questions can potentially be at least addressed in part by using the Onyx color check verification tools. And they provide a means to ensure that you have a standard level of output quality using some sort of a standard. You can use G7 standards. You can base it on printing standards, or you can use the Onyx print gamut verification to understand whether or not your profile is printing colors that are in gamut correctly. In addition to understanding whether or not you're actually printing things, you can print things correctly. A second thing to really consider is whether or not you're printing consistently. How often do you check that things are printing consistently? Do you just assume that it prints the same today than it did yesterday because it looks the same? How do you ensure that printers that share profiles are printing the same? Many places actually have multiple printers, and if you have one printer printing and have three printers printing the same multiple copies of things, how do you know that they're actually all printing the same? The integrated aspects of color check tools within RIPQ, along with the regular use of baseline color check verification, provides a convenient means of evaluating print constancy. In thinking about doing process control, we spent a lot of time and a lot of effort to come up with mechanisms within RIPQ that are integrated. They're seamless. Performing process control is really a print operator function. It's not necessarily somebody that does the profiling is doing. The print operator has to ensure that they're producing the same results day in and day out. And so we want to have tools that were basically within the realm of what the print operator is seeing and doing to ensure that it's done. So let's talk about using color check. And I'm just going to talk about a basic overview of color check as it's integrated in the Onyx product. If you have color check as an enabled feature in the software, then in RIPQ in the upper right hand corner, there's an additional tab next to the print setup tab, which is the color check tab. And this color check tab basically gives us information about when color check's been used, how it's been used, and when the last time you did it. So when you go to that color check tab, you can basically, very simply, if you've never done color check before, you just go to that tab and you click the print color check button. This will bring up a print swatch dialog. Now the print swatch dialog, when you first install the system with color check, has three default swatches that you can select. And in this case, we're going to basically select the Onyx Weekly Baseline swatch, which basically has about 72 patches, and we're going to basically print those things out. The patches themselves kind of correspond to the Fogra Media Wedge, but they're not necessarily color managed to do that. We'll talk about that in a bit. And in addition to setting the swatch you want to print, you're going to specify the color device you're going to use to measure it. You're going to specify the printing setup, and by default it'll use the media that's currently selected on the printer, and you got to specify the mode, the QuickSet you want to use for as color management's applied, and a few other settings for how it's printed. Once we push the print button, then the job will be created, and it becomes a swatch job, which is a new kind of job in RIPQ. Remember, this is basically something that's fundamental to the print operator. And so we don't have a wizard in Media Manager to do this. This is integrated completely inside the product itself. So the swatch will show up in the job, and it will be actually a swatch job. And if you do job previews on it, you'll basically get information about the swatch as opposed to the job. And rather than going into a job editor, once the job itself is finished processing and printing, then the job will go into the waiting to measure state. And so it's basically waiting there. The nice thing about this is that basically the use of color check is kind of just basically a part. The swatch itself can be nested with other jobs and printed with other jobs, so that you can basically get an idea, or feel the temperature of the printing process at the time you print. And then after the jobs are printed, the jobs themselves go down to the waiting. But after the buffered area, after a swatch job is processed and printed, it stays up in the active queue area, going to a wait to measure state. And it'll stay there until you do it. So the print operator doesn't necessarily, unlike being a wizard, we have to do this, this, and this, and it could interfere with their work. They could basically do the printing, and then they got a rush job, they got to get all that stuff taken care of. They can do that, and then they can come back and measure the swatch to find out and get an assessment of where they're at, if they feel that it's functioned pretty well. Once you push the measure swatch, then it basically brings up a swatch measurement tool. The swatch measurement tool there does the measurement, and then it will, after the measurement's done, it will then show a report based upon information in the swatch itself. The tests that are done roughly correspond to the tests of standards, and the idea is basically you print within tolerance. Now, since this is the first time that we've actually printed this baseline swatch, the metric, the differences are zero, because with a baseline swatch, the whole idea here is to determine whether or not you're printing consistently. And so the first time you print, that's when you establish how it should measure. It doesn't determine whether or not it's measured correctly. It just determines this is how you actually are printing at this point in time. When you do baseline again, then the measurements will actually show you the difference between that, and you can see whether or not how far things are drifting. And this allows you to see whether or not the printer is printing the same, or if you change the media, the print output potentially changes, or you change the media. All of those things basically show up in the verification as you get further and further out of tolerance. Now, once you actually have this report, you can basically save that report as an HTML file, which can then be used to keep a log of all the things that you've done, and you can see what's done. You can print this report out from a browser, and you can look at various things and do some um, various operations. You can click on tabs at the top here to see which patches are actually the worst, so you get an idea of which colors are maybe potentially. If you have something where all the colors that have cyan in them are bad, that may be an indication that there's something wrong with the cyan head or the cyan ink. If you're looking at light colors and the light colors are out of spec, that may be that there's something wrong about the media because you're not measuring the media the same. Um, an additional thing you can do, you can basically view and save out the measurements themselves for um, um, other applications that may actually use measurements to do tracking of things. So you can basically integrate this with other systems that may actually take into account the measurements themselves over the long-term tracking. If you have any problems along the way, you also have access to the color check reference guide, which is basically a 30 some odd page document that basically goes into great detail of some of the things that I'm talking about here, with some tips and advice about setting up process control system in your environment and using the color check tools in Onyx RipQ to um, um, verify how things are working. Could somebody please push mute? Somebody's typing. Okay, so let's talk about color check swatch management, because the thing is that color check is basically a general concept in there, and we have various different kinds of color check swatches that allow you to do different kinds of things. And basically, there's basically three modalities, you might say, of using color check. One is to discover and track color consistency, and the baseline swatches are for that. To determine color accuracy, you have the G7 Master to some extent, the standard simulation swatches, and the print mode verification swatches. And then for informational swatches, you have name color swatch, name color evaluation, and the ability to have basically a custom image that would potentially be used by some third-party process control tracking system. I'm going to go into a little bit further detail for each one of these swatch types and to understand the workflow and what's going on there. Um, Selection and management of color check swatches is done using the configure color check button. It's on the toolbar of RipQ when color check is enabled. I'm not going to go into great detail over a lot of the stuff in here, and I really do recommend people check the color check reference guide for further information about using and working with custom color check swatches. I'm going to drink here. Okay, so let's talk about color check workflows, talking about those different kind of swatches. And I want to talk about workflows. I'm going to have some kind of workflow diagrams that talk about sort of what's going on. It's really helpful to understand what's going on when you're doing color check, because when you get the big red X that says something bad's happened, knowing what are the possible causes and the contributors to that are incredibly important, especially when you're just starting getting into color check. So let's talk about differences between color check workflows. And here again, I'm going to talk about some questions. And these are questions that basically are related to how you can kind of differentiate between the workflows. And the first question is, how are colors specified? Okay, and each one of them basically with the color check, you're going to you have a set of colors, you're going to put a swatch with those colors, you're going to measure those colors, and then you're going to see what the result is. And so the first question is how the color is specified, and then but the next really big question is basically what process is going on involved in converting the colors that you have to what you need to print. And then once you've actually done measurements of the printed results, well, what are the expected measurements going to be? And how do you determine what those expected measurements are? And then once you've actually got some measurements and actual measurements and expected measurements, and so what tests are being applied to those measurements? okay? So think about these four kind of things as we actually look at the actual baseline at the basic workflows here. So let's look at the baseline swatch and the workflow related to the baseline swatch. Now this right here is, there's really two parts to baseline. The first part, baseline, is when we create a baseline. So the first time we print a baseline swatch for a print mode, we're basically creating things. And so with this right here, we're going to start off with a swatch definition. Now, baseline swatches, you can use the Onyx baseline swatch. You can create your own baseline swatch, and basically a baseline swatch basically has definitions for individual patches. The patches can be defined as ink values. They can be defined as C-Lab values, or it can actually have like name color spots. And the part of the swatch, for each one of these different types, we have different things are going to be, different kind of transformations are going to be used to actually get to the point where we actually have device values to print. For ink values, we're going to basically convert to mode device values using some simple math. It's kind of like basically turning profiles off if you're basically using a job that has ink amounts in it. And we're going to print those basically directly. With C-Lab values, this is going to have color management. We're going to basically apply the profile that's associated with the print mode. If we have a name color, then we're going to basically look up what the C-Lab value for that name color is, apply the profile, and get the device values. Then we're going to go through the process of printing those device values, applying all the stuff that you have in terms of linearization, ink limiting, ink restrictions. Not necessarily ICC profiles, because if you did have that, that would be up front here. We're going to process and print that swatch, then we're going to measure it, resulting in C-Lab values for the swatch itself. We're going to take those values and we're going to store the actual C-Lab values inside the print mode itself, which means that basically if I export the media containing that print mode and I import that media somewhere else, those baseline values are now on that other system. And so if somebody's actually in the process of doing profiling, I strongly recommend, after you do the process of profiling, to actually create a baseline swatch for that, so that anybody who's using that print mode can then basically run the baseline swatch again and compare to see whether or not you're printing the same as when you did the profile. Now, this right here is the creation. When we actually do validation, it's very, very similar. Basically, the stuff to get to the point of having C-Lab values is identical, except for at this point in time, we're going to retrieve those baseline results from the print mode and compare them, and then apply the tests. Now, when you're creating a baseline swatch, in addition to defining the actual patches, you can also define what tests you want, which means which patches are involved and what sort of operations. Do you want to have the mean to be something, or do you want the minimum to be something, or the maximum to be something? And then once we actually have all those tests done, the report is generated and shown to the system, and then we have reporting various ways of dealing with those reports and using them in the software. So baseline gives us the ability to check to see whether or not we're getting consistent results, because the actual values that we're actually checking to see are based upon something we previously printed. Now, if we're using a profile in the print mode that was totally inappropriate, I basically just downloaded some profile, plugged it into the system, I'll get device values, but that profile doesn't actually correspond to how it's printing. Using a baseline swatch, I will not have any information about whether or not it's printing correctly. All I'll know is that basically from the time I start using it, I can guarantee you that it'll print the same. So, you may be, if you like the way that profile prints, that's fine. With baseline, you can just make sure that you're always getting the same results. Now, let's move on to something with more standards. And in this case right here, you have basically CMYK inks in a G7 workflow. In a G7 P2P swatch, there's CMYK ink values. Some of those inks are got CMY combinations. Some of them have black combinations. And really, basically, the idea with G7 is you're basically going to print those out. And for the CMY combinations, you should get those combinations should actually appear gray. So basically, the A and B values should be at predicted values close to 0, which is neutral. The black ramp will also printed, and so in addition to that, it also looks and checks to make sure, based upon the maximum density of the CMY or maximum density of the black, what the tone is, and basically do you have a predictable tone based upon the G7 specification. Now, when we're doing G7, there's really two kind of ways we can go about using G7. One is we can basically apply the color management involved with the quick set. So if we have CMYK values in the data characterization data, we'll then apply the input profile for the for that, apply the printer profile, and get the device values. This right here is basically determining how well your input profile, assuming that your printer profile is correct, it determines how well the input profile for the quick set conforms to G7 standard. If you're using one of the CRPC profiles provided by CGATs, and from people who advocate G7 workflows, then you're more likely to do it. If you're using some other profile from some other standard, it may not necessarily have the black generation set up to give you the same results. And so basically, when you get the red X, it may be more to do with your input profile selection than anything else. In addition to that, you may actually, in terms of the profiling process in the Onyx product, actually create a G7 calibration as part of the profiling process. In which case, what you're going to do is you really don't necessarily want to use the input profile. What you really want to do is you really want to basically take those inks and convert them to the device mode, to the print mode's device values directly without profiles, and see whether or not the calibration itself is actually meeting the G7 standard. In which case, this right here is the CMYK inks are printed directly and go out. This is a very valuable thing to do if you're actually using G7 for your calibration. If you use the color management, whether or not you use the G7 is kind of mixed up in terms of the profiling, because it's in addition to the G7 step of the calibration process or profiling process, it's also applying the printer profile, which may or may not actually preserve the characteristics of the G7 calibration. Once we actually have device values, the processing and printing and measuring is pretty much standard in terms of all of the color check systems, and you're going to get CLAB values. With those CLAB values, we're going to basically look at those CLAB values, and for the CMY grays, we're going to make sure that those are gray. We're going to look at the tone values, basically apply all the tests that are defined by the G7 standard for validation, and we generate the report. Looking at another kind of way of doing standards, you have other standards. You actually have standards, like ISO 2067. I can't remember the numbers right now. It's been a long time since I looked at them. But you have standards for whether or not you got FOGRA, meaning FOGRA standards, or GRACL standards, Japan color standards, whatever standard it is you want. Usually those standards are basically related to printing with some sort of a press, which has a standard printing condition. In which case, what we start off with is you start off with a characterization data set that has two pieces of information. It has CMYK values that you're supposed to print on said press, and what the expected CLAB values are going to be. So in this case, both the definition of the color and the expected results are actually provided up front. Now, when we actually go to print those things, in this case, if you're printing on an inkjet printer, you're likely not to be using the same color of inks as they're actually in offset presses. So your medias, the white point would be completely different. So if we basically take those CMYK values and print them out directly, which you can do by basically saying don't use color management from a quick set, you'll be printing those CMYK values, and the end result will actually tell you basically how close to a press are you printing without using color management, which may or may not be valuable. Most likely with people who are doing standards validation workflow, they're going to want to be using a quick set that defines the input profile for CMYK images. It'll apply a rendering intent and the profile. Now, if you're using this and trying to validate being correct, the rendering intent can be very, very important. If you use a perceptual rendering intent, it may not necessarily give you the actual colors you'd be printing if you printed CMYK directly without any color management on a press. So making sure you have the right profile. If you're basically using a characterization data set for Fogger 39 and your quick set is set up to use a Grackle input profile, they won't match. And so the inconsistency between the characterization data set you use and the profile will cause problems. And basically when you get to the end and you have a problem, the problems themselves may actually be in terms of how you set up things, as opposed to whether or not your printer is actually capable of doing stuff. We're going to be applying the profile, and one other thing here, since we're applying color management for both the input, your printer itself may or may not necessarily have gamut suitable to cover the characterization data set that you're doing. If you have something you're printing on textile and you're trying to print something for a glossy media, it will be potentially way out of gamut, and so it may not necessarily even be valid for the standard that you're using. Using standards that don't necessarily directly apply is one way to be for disappointment, and so got to be very careful about using standards to make sure that the standard that you're using actually has a good correlation to what you're printing with. A lot of the stuff that's being done in large format printing is not going to have the same medias and inks, and so it may or may not tell you whether or not you're actually printing correctly. So in this case right here, begs the question: what does it mean to be correct? If you're not printing on a press, if you're using a press's data characterization to value correctness, well, you've already violated because you're not in that realm. So once you've processed and measured, then what happens is that basically you have your measurement data, and then you're going to compare it to the measurement data that's in the characterization data set. Now, you have some things to be able to basically kind of reuse those kind of things. You could potentially apply some profile-based substrate correction because, the characterization data set is for some particular paper, and I'm printing on some other kind of media. I want to print pretty close to being the same, but the white points won't be there. And so basically by applying a substrate-based correction, you can basically say, I'm printing similar, but we're going to allow the white points to differ. So that's actually a possibility when you actually print this swatch, to basically specify that you want to have the substrate-based correction here. Once we've basically got the decided on how you want to do the validation values, we're going to compare those and apply the tests that are associated with the standard and generate a report. Now, the previous two are methods, basically the G7 and the standard validation workflow. These are both ways of determining whether I'm printing quote accurately based on standard CMYK data sets. They have the requirement that basically that if I'm going to use color management, then I got to have the color management set up, and you can potentially have some problems there. One thing this doesn't do is this doesn't necessarily tell me about colors that I can print with my printer that are not used by the characterization data set. If I have a CMYK orange blue printer that has a really wide gamut and I use a characterization data set that's fairly small, I will check to see whether or not I can print those colors accurately. But what about the colors outside that? This doesn't tell you anything about that. So because of that limitation, at Onyx, we generated our own verification system where we could basically use the printer's profile. So basically, when we profile a printer, we know colors that the printer can print, and we know colors the printer can't print. So what we're going to do is we're going to look to see the colors that we know that we can print, and then we're going to apply the profile and print with that profile, and then see how well the profile predicts what we expect the profile to produce. Okay, so we're going to basically determine colors that are in gamut as LAB values. So we're going to look at the profile, look at the gamut shape of the profile, and take colors that are inside that gamut that cover various hues, lightness, chromas, saturations, and stuff like that, and generate a swatch of LAB values that we know that are in gamut. Okay, and so we're going to determine those LAB values. Then we're going to apply the printer profile to those LAB value. There's no input profile here. We're only basically looking at how well the profile itself, or how accurate the profile is at predicting and reproducing colors that the printer, we know that printers should be able to reproduce. We're going to end up doing the device values, printing those, getting the measurements. Okay. Then we're going to take those C-Lab values. We have the option of applying media-based substrate correction, because print gamut verification, if you're printing on things like UV cure machines and stuff like that, where you're using foam core and stuff like that, there's you can basically have some wiggle room in terms of changing the media and getting pretty similar results. And so basically applying a media-based cut substrate correction allows you to basically use those situations where you don't necessarily have to have an exact profile for every media. At least you can get an idea of how close you're getting when you're doing that. So we're going to basically take the C-Lab values that are in gamut versus basically printing them and measuring the results, and then apply tests to see how well this works. Print gamut verification is a really useful tool to determine how accurate a printer profile is. It doesn't get muddled up with the input profiles and stuff like that. And using the print gamut verification workflow is critically important. It can potentially be important if you do a standards-based test and you get a red X. If I get a red X, is it because the gamut, my input gamut, doesn't match the output gamut? Is the problem because my profile is inaccurate, or is the problem because the printing system is not good? And we'll talk a little bit about the process of doing kind of troubleshooting in just a little bit here. Another color check option you have is what's called name color evaluation. In this case, there's no testing. What we're doing is we're going to start off with a swatch that has named colors in it. These are basically colors that would appear in PDF documents or PostScript documents, and they, Pantone 402, whatever brand colors people are using. And you want to have an understanding of how well you can print those named colors, how close you can get those named colors, the reproduction of those named colors. Okay, so we're going to have those named colors. We're going to do a lookup and get C-Lab values, or alternately, we can basically get, if you're using the option where a print mode defines the device values directly, we'll just basically look up and get those device values directly. Once we have the LAB values, we're going to apply the printer profile to get the device values, and then we're going to print the device values and measure them to get the measured results. If you're using print mode defined colors, we're going to apply the inverse profile to actually get the C-Lab values for comparison. So there's two possible ways of getting of determining what it means to be correct. It's either going to be the C-Lab values, or it's going to be basically, if your print mode says this is the color I'm going to print with. In many cases, people can have, a color that a name spot color that you can't print. And so you'll go into the mode and you can say, well, I'm going to print all these things. This is the actual CMYK orange, whatever color I want to use to print. Okay. At that point, you're making a decision of what you do want to print as opposed to what you can't print, because it may be that the color is out of the gamut of the printer. Once you decide that's the color, then that's what you really want it to be, and you can see how close you're getting to what it is that you actually decided. Telling it to use mode defined colors, your accuracy goes way up potentially, because at that point you're now looking at colors that are in gamut as opposed to colors that are actually the standard. You also have the ability to take into account media-based substrate correction. Now, once we've actually printed and measured out, we're going to compare them to what we expect the color to be, and then we're just going to generate a report. So all we're doing is showing color differences. We're saying, hey, for this particular color, this is how close you got. For this color, this is how many close. And then on the average, I got 15% of the colors were under 2%, 25% of the colors under 50%, and the rest was really bad. And so the relative percentages of 2%, 5% can kind of give you an indication of gamut size. But it doesn't necessarily tell you whether or not you're accurate. Okay, well, we'll get to that for a second. So let's just basically kind of wrap up all of this workflow discussion into a single chart. And basically going back to those 4 questions in terms of the color specification, color conversion, measurement definition, and tests. For the baseline swatch, it defines color consistency. So you have lots of flexibility in terms of what colors you want to print in a swatch. Generally, for ink color spaces and device color spaces, there's just basically simple numeric, no profiles applied. And we're going to basically take measurements the first time we print the baseline swatch and then compare to it. You do have the option, you can go to Media Manager and you can delete the baseline measurements and then start over in case your printer is now printing differently and you just want to use that as your baseline. And the tests themselves are user defined. We come up with one baseline swatch that you have. You can basically make copies of that, change the test, add patches. You can create your own baseline swatches. If you have particular customers that have specific spot colors that they're interested in, you want to make sure that you're printing those consistently, then you can add those to that and make that part of your baseline. So really the key is baseline is a really simple, convenient means to make sure that you're printing the same day in, day out, and it doesn't require anything. And when we have problems with the baseline swatches, because we're not necessarily applying a lot of color management, we're basically just comparing, and we're not necessarily deciding that we want what accurate is. We're just comparing to how we have printed. It can tell you when things have changed, like media, ink, environment, or the printer functionality. The baseline is a very good, simple, quick thing to say, I am printing consistently, and when you're not, then you can start looking for what the causes are. With the G7 print standards and print verification, in those cases, basically, we're trying to measure against something that we know as, quote, correct, okay? For the G7 print standards, it's based upon CMYK, and if you're not using a CMYK printer, then you're only testing a subset of what's being printed. And for G7, you may want to use the numeric, just basically see whether or not your G7 profile and your calibration steps are correct. For printing standards, you're more likely to want to be using color management to see how well you're printing CMYKs according to that print standard, and you're basically comparing it to the actual expected measurement for those things. And the tests themselves are defined by the standard itself. Print gamut verification, unlike the other two, it's really basically only dealing with the output profile. So print gamut verification is an excellent tool to determine whether, after you've profiled, how accurately you can print with how accurately you can print in gamut colors. It doesn't tell you about what happens to an RGB image that's outside the gamut, but it does tell you that once it's actually mapped to the gamut, how accurate you're going to reproduce things. And those tests are ONIX defined. With name color, this is only informative. We're not necessarily saying you're not going to get a red X on a name color saying I'm not good. All you're going to do is you're going to say, hey, you only get 3% of the colors with under 2% or whatever, and you can potentially decide whether or not that has meaning yourself. So that right there wraps up various workflows, and understanding these workflows and how they interoperate with the color specification and the measurements is critically important to understand in terms of what you're trying to assess and how you're going to what you have to do to fix things if you have problems. One additional feature in the software is basically when I'm printing jobs, I may actually want to understand for the particular colors, not necessarily for arbitrary colors. When like if you print a Pantone name color chart, you can see basically how well you can get those Pantones. But in many cases, I get a print job, and what's really critically important is how are the 5 colors that this print job print? How accurate can I get them? Well, before I do that, name color evaluation. As has been previously mentioned, this basic report basically it gives you an idea of the print mode's color capability. When you look at it and you basically see the overall, where you can see, overall I'm only getting 8% of my patches are 2%, and 41% of them are 5%, and 70%, 73% are like 10 patches. Under 2, it's probably not so you can't really necessarily tell the difference. Under 5, I can notice it, but it's not too bad. 10, yeah, it's pretty bad. And if you're beyond that, wow, it's way out there. In this case right here, this may actually basically indicate that we're printing on a media that doesn't have a very big gamut. Either that, or I may be using a profile that is completely inappropriate for what I'm printing on. You can see actually, there's no distinguishment here between basically being accurate or out of gamut. I can have colors that are in gamut that I'm not reproducing well. That's an indication of a bad profile. Or I can actually have colors that have big numbers, and it's just because that color is outside the gamut, and you really don't have any distinction made for that particular information. In addition to that, it also shows you basically, whoops, I got to be very careful about pushing. You got to be very careful. Got interrupted. You have at the bottom here, you can actually look and see for each one of the colors defined in the name color, what the measured value is and how close it was. You don't get to see what the actual color LED is, but you can actually see what was measured, and you can see basically the color difference in terms of delta E 2000. And by clicking on these buttons right here, you can sort them so you can find out which colors are the worst, which colors are bad, the best. And from this right here, you can also print out the swatch based upon that sorting. So it's very, very useful in terms of understanding the colors you have. In addition to that, as I said, you want to potentially find out not about all the colors in the Pantone, but maybe what about the colors that are involved in a job. Now, with a job, when you go to job properties, if you click on the name colors, you get a report of all the name colors that are in that job, in that PDF file. Some of those, any of those that are actually defined in the name color table, cut contour, are not ones, and so you don't need. You also have, based upon the profile, what the estimated color difference should be. And so in this case right here, I got 9.8. Hey, that's probably not in gamut. So you can get a good idea of whether it's in gamut. But this doesn't necessarily tell you how well it prints. This tells you how well the profile thinks it will print, which is a different thing. So you now have the ability to either get that from job properties in the RIPQ, or if you do info for a job in Job Editor, you can also get the same thing from there. In either case, we can push the print color check button, and for all of the name colors in that job that we actually know about, that are actually in the name color, spot color replacement tables that we actually have, it will actually put those things into a color check name color swatch, and it creates a special one. So when I say print one, it'll basically create a swatch, NC underscore with the name of the job, and that will be a name color evaluation swatch, just like any other color check swatch in RIPQ that'll be processed and printed. So what I can do is, before I print my job, I can go in, print a color check swatch out, measure it in, and see for these whatever 15, 10, 5 colors that are in there, how well I I get those colors. And the nice thing about that is this tells you exactly how you're going to print them, how accurate you're going to print those colors, as opposed to the guess of using the profile. And be aware that the profile may not necessarily accurately predict how well you print. It may say you do a really good job, and when you print it, it may not be so good. Okay, let's talk a little bit, just one quick thought here about profiling and color check. Okay, and really basically color check has its place in the profiling process. And really the key here is that basically after you create and profile a print mode, measure a baseline color check swatch. The nice thing about that is that basically this allows you to see how well you're able to reproduce printing. If you're basically doing print modes for, you're a reseller or somebody who's profiling media, make sure you create a baseline swatch, because at that point you give it to somebody else, they install it in the system, and when they print, if they have problems, you can say, hey, print and measure a baseline swatch. And if you're out of whack on the baseline swatch, then it's not because you've got a bad profile. It may be because they're using the wrong media, they're using the wrong ink, or their printer itself needs to be serviced. Baseline swatches are very, very useful for understanding, basically, being able to notice when something has changed. Figuring out what has changed is a separate thing, but noticing that something has changed, baseline swatches are critically important to help you do that. Also, after you've done some profiling, you can basically use something like the print gamut verification swatch to get an idea of how accurate you can print in gamut colors, or you can use some other standard. If you care about reproducing the standard, then that's important. But basically, after you do the profiling, you want to do basically something to potentially assess how color accurate things are. Now, the real cool thing is I do my profile, I print a big swatch that assesses how accurate it is. Once I've identified and say, I know that this print mode has a sufficient level of accuracy, then I don't need to necessarily do that reassessment of accuracy over and over again. All I really need to do is use a baseline swatch that ensures that I'm printing that accuracy consistently. So assessing color accuracy can be something you do less often, and something where you can see once you've actually established your accuracy, the more important thing is being consistent. Okay, so we've talked a lot about using color check and how the workflows work and all that fun stuff. Let's quickly talk about the color check verification process. Now, what does it mean when a color check, basically goes out, you basically get big red X's that says, I failed the tests, and really question, how do you determine the source of the failure and what you can do to fix the failure? I can't necessarily, don't have time to go into great detail about this. This is a really important thing. We spend a lot of time thinking about this, and there's a lot of troubleshooting guidance that's actually in the color check reference guide. So I basically would advocate people looking at that. But I'm going to go over basically three simple kind of flow charts for looking at in terms of verification. So baseline. This is basically determine whether or not we're printing correct, printing consistently, right? So if we pass the verification, we're good, right? So if we don't pass, well, are we using the correct print mode, the correct media, And if we're not, then hey, we're we're just not using the right thing. You got to use the right and print mode media. We're going to then potentially check for the printer maintenance and potentially do recalibration, and then do another verification. So basically, we'll do some things to tweak the maintenance, the calibration, do a baseline verification. Does that take us back to where we want to go and be good? Then we're good. Otherwise, at this point, maybe something's changed. The printer itself is not stable. The media has changed. The ink has changed, or maybe the print environment's changed. And so those are things you need to check for. So baseline is basically, am I printing consistently? And then help me understand what's changed. And so and then you can probably rectify things, and then you basically do the baseline verification to see whether or not you're getting back to where you were. With standard stuff, then things are a little bit more involved because in this case, when we get a failure, the question is it because of things that are changed in terms of the printing? Is it problem due to the accuracy of the profile, or is it problem due to the input settings that you have? And so this workflow here, this flow chart, I'm not going to go into great detail here, kind of talks about those things. With the print verification, it's simpler. It's in addition to understanding that something's changed, you also can get some sort of basically sense of how accurate your profile is. And if it's not a maintenance thing or maintenance thing, then maybe the profile is not quite as accurate. And so maybe you want to consider using an AccuBoost to try to get a little bit more accurate profile generation. Okay, so ColorCheck provides an integrated tool set for within RipQ. We tried to make it as user-friendly and as simple as possible. The tools, with these tools in place, your printer operator can easily assess your print accuracy, as well as ensure that your print results are consistent day after day for multiple printer devices of the same make and model. It simplifies the implementation of maintenance of process control with a printing environment, which can improve efficiency and reduce waste. One thing I haven't necessarily mentioned here is that ColorCheck is like driving with a seatbelt on. You know, if you're not doing things for process control, you're driving. You maybe think you're driving safe, but you don't have that seatbelt to protect you, to tell you not that something else has happened. We've had customers who use the ColorCheck, you know, where they were printing and they got a new media and the color changed. They were looking at the output, they didn't see the difference necessarily, but they were actually, the colors were different. And if they got their customer, the customer maybe compared it to something that was printed previously, they would say, "I got a problem here," and then all that printing may be a waste. It saved them thousands of dollars to know that happened, and all they had to do is go back in and recalibrate or talk to their media person. This is a way to basically ensure that you save time and money. In all actuality, ColorCheck will pay for itself. I guarantee anybody who gets ColorCheck, eventually it'll pay for itself because it'll point out a problem before you actually know it and allow you to address it before it becomes a waste of time and money. How do you get ColorChecked? Well, it's part of Thrive 19 with Advantage subscriptions. Existing customers, if you need to upgrade to 19, you can get access ColorCheck through Advantage subscription. New customers can get it through the license, and I suggest that you contact an authorized reseller or email sales. And that's all. Thank you very much.
Thank you, Max. I'm looking at the chats for any questions out there. If anyone has any questions, you can send a message through the chat field.
I see three that were sent to me privately.
I might not see that. Okay, go ahead and take that.
Okay, I'll take the first three here. When considering the standards validation workflow, are there any situations where you would not recommending using device links? Oh, that's a good question. Let's see. Using device links, actually ColorCheck actually works with device links because basically it uses the color management defined in the quick set. So if your quick set is set to use device links, you will use device links. Whether or not you want to use device links may have to do with whether or not you want to see how well the color would happen when embedded profiles are being applied, because when embedded profiles are applied, device links are not necessarily applied, and so you may actually want to get an understanding or a validation of that situation. Can you use the print gamut verification to compare a gamut between printers using the input color profile to generate CLAB from a different printer? The option seems to be there, but would the information be reliable? Now, print gamut verification doesn't use the input profile, so it does it. And it doesn't necessarily give you an indication of gamut size. All it does is it tells you how accurate you can print colors that are in the gamut of the printer. That's one thing. That's about print gamut verification. Print gamut verification is a tool to see how accurate the profile is, not to qualify the profile as being a big gamut or a little gamut. Actually, if you really want to get an understanding of potential gamut size, in using color check, probably the best way to do that is compare the in color results for different printers, because if you have a larger gamut, you're going to get more colors that are in gamut, and basically you can combine, say, the print gamut verification and the name color. If basically you're accurate and your gamut, your name color reproduction is low, then that tells you I got a good profile, but it's got low accuracy. It's got a small gamut size. If it has high accuracy and you got lots of colors, that gives you a better thing. But if you have low accuracy on the profile, then the name color doesn't really tell you much. So that's how you can use those two together. Let's see. Will calibration of the printer that you're checking be taken into account when checking a supplied profile's baseline? Yes, because the thing about it is that if you looked at those workflows, when we're printing out any of these color check swatches, we're applying ink limiting, calibration, ink restrictions, and stuff like that. So you're basically printing kind of in a state. So basically, when we do the baseline, the calibration is applied for the baseline and for the first time you print. When I print a baseline swatch later, I'm still using the calibration, and it applies that and sees that. So if you do a recalibration, the recalibration also gets applied, and so you can potentially see that, hey, I'm getting back to that known state, and how close you get. Let's see. There's a is it Gold Advantage only?
Yes, I replied to everyone that it's with Thrive and Gold Advantage only.
Yes.
And I believe
So,
that's on our web page for the Onyx Advantage agreement, I believe.
I will admit that I am somewhat disappointed in how it's licensed, but it's a really important thing, and as I said, it does pay for itself. PowerPoint, I don't know. We're going to have to talk to the salespeople about how you're going to get information about this. On inkjet printers that use silver and white ink, can those be added to the baseline checking? Yes, they can. The measurements themselves of silver and specialty inks and stuff like that will be what it is. It's basically, are you getting the same measurement today that you did yesterday? And when you're creating baseline swatches, you can define any colors, including spots, I believe. And so they part of your baseline swatch.
It looks like a last question. Does Color Checker support Contone printers?
Color check applies to any printer you can print to from RipQ. Okay, because it basically uses the printing mechanism. It will do the color management just like you. I mean, if you're using a standard stuff, it uses the output profile. If you're using print gamut verification, it uses the output profile. So whether you not have an RGB color space or a CMYK orange, green, white, silver color space, all of those get applied, and so it applies to everything.
Let's see. There's no other questions. Max, would you mind making me the presenter again?
I would love to. Let's see.
I've got something I want to show from our webpage. I got it ready here.
Let's see here. I'm going to stop sharing.
Okay. For me.
I don't want to leave. Maybe you can take it from me.
Yeah, I'm trying to, let's see here, participants list. Reclaim host role. Okay, kids, we're getting there. All right, presenter. Okay, wonderful. So I want to share this out. Bring this up on the screen really quickly here. So on our website, onyxgfx.com, up at the top, I went to products, and then I went to, at the very bottom, Onyx Advantage. So for the question, there's this little chart that will break apart and show the silver advantage compared to the gold. And this is where it'll identify at the bottom color check. And that's what I just wanted to verify and show. That part of it is part of that particular with Thrive and the Advantage Goals plan.
Where's baseline?
Well, I believe it's going to be here. Check baselines are process control, access
Got
to
it, yes.
baselines. Yep.
Got it there. Okay, cool.
And just as Max mentioned, when you make a Myonix account and you go into the Myonix documentation, we do have a very good detailed document, PDF document about color check. It is a 40 something page document, but it's a very good one. And it does explain in great detail the differences of the different test targets and the idea and the analogies of what you want to go through when you first get started with your process control and troubleshooting at the end. So it is a very good document as far as that goes for reference materials. So you guys can go into your Myonix accounts. If you don't have one, you can easily make one up. Here's at the bottom of page 2 for now. That's where it's positioned. Our reference guide. You can click on download. And like I said, it's a 47-page document, but it's very good. It talks about all the different things to consider. And then it goes into explaining the different types of test targets and what's involved. So just to make reference to that, it's a very good bit of documentation as well. All right. Well, I'm going to stop sharing my screen out and believe that's going to be the end of the questions. Thank you all for participating. Max, thank you for a wonderful presentation.
My pleasure. Have a good day. Be safe,
All right,
everyone.
everybody. Yep. Have a great day, everybody. Take care.